Okay, in this lesson, we're simply going to introduce a few new identities, and they are the sum and difference of angle identities. And we're going to use these to actually find the sine or cosine or tangent of angles that we don't know the exact values. And what we're going to do is actually use the angles that we do know the exact value of. And I do have my unit circle pulled up. And I've got all the different angles that I know the values of here, such as my 30, 45, 60, and so on and so forth. And what I'm going to do is actually use those angles to find the sine, cosine, or tangent of the angles that I don't. So here we go. The first thing we're going to actually do, and you can see the identities there, and I'm not going to go over all those. But to actually find, let me zoom in, the sine of 165, I'm going to try to find two angles that I actually know that add up or subtract to give me 165. And I can go back to my unit circle, and 165, let's see, these two would work, 120 and 45. I know those two values, and I know that I can rewrite the sine of 165 as the sine of 45 degrees plus 120 degrees. And what that does is that actually matches now my sine identity, my sine sum or difference identity. So the sine of A plus B is equal to the sine of A, cosine of B. And in our problem, we know that A and B would match up with 45 and 120. So everywhere I have an A, I simply put 45. Everywhere I have a B, I simply put 120. So let me take and actually write that out. And from there, I'm simply just evaluating those. So the sine of 45, I know that's one of my more common sine values. That's root 2 over 2 times the cosine of 120. Now, 120's cosine, you got to be a little bit careful here. 120 is in the second quadrant. All students take calculus, so that cosine value is going to be negative. So I'm going to put it in some parentheses there. Then I simply mark out the 120. I find my reference angle, which is 60 degrees. The cosine of 60 would be 1/2. So therefore, the cosine of 120 is negative 1/2 plus the cosine of 45 is root 2 over 2 times the sine of 120. So I do the same thing. All students take calculus. That will be positive in the second quadrant. My reference angle is still 60. So therefore, that would be root 3 over 2. Then again, it's simply cleanup. Positive times a negative here is a negative. Multiply the tops gives you root 2. Multiply the bottoms gives you 4. Plus, you can actually multiply those roots. Root 2 times root 3 is root 6 over 4. So there's your answer. You can combine, since you have a common denominator, you can combine the tops. And I'm going to leave that, actually, since the root 2 is negative, I'm going to write my root 6 first. I'm going to do root 6 and a negative root 2 all over 4, and we're going to leave our answer like that. What we do not want to do is we don't want to turn that into a decimal for this reason. The sine of 165, we could have typed and straightened our calculator and got the decimal answer, but I do want to go back to the directions. It says find the exact value. So that's the reason we're gonna break them apart and we're gonna leave them exact. We're not gonna turn them into a decimal. So the cosine of negative 75. So now we got to find two angles that subtract or add to give me a negative 75. Now, one thing you can do there, if you would like, is anytime I'm dealing with negative angles, a lot of times I will add a rotation to that, which is perfectly legal because negative 75, when added to 360, is going to give you 285. Those two angles are coterminal. They're basically the same angle, just with an extra rotation added. So it is perfectly legal to do that. So if you would rather do negative 75, if you'd rather do 285, it doesn't matter. I'm actually going to do 285 just to where I don't have to deal with so many negatives. So let's try to find two angles that add or subtract to give me 285. And there's my unit circle. And there are tons of options here, and I'm actually going to use maybe 225 and 60. We can use our angle sum. So 225 and 60, let me go back to it. So we're going to do the cosine of 225 plus 60 degrees. And again, that fits. Let's scroll back up. The cosine of a plus b, cosine a, cosine b minus is in the formula, sine a, sine b. So our a value is 225, our b value is 60. So let's go ahead and plug those values in. And there are your values. So now let's go through and evaluate each. So first off, the cosine of 225, 90, 180, 270. So we're here in the third quadrant. All students take calculus. So therefore my cosine, and since it's negative, I'm going to put in parentheses. My cosine value will be negative. My reference angle there is a 45. So I can now mark it out and put a 45 since I have my negative symbol. Cosine of 45 is root 2 over 2 times the cosine of 60. That's a really easy first quadrant angle, is 1/2 minus the sine of 225. That's the same 225 right here. All students take, so that'll be a negative. Let me try to fix that. That'll be a negative value. Again, my reference is 45, so that'd be root 2 over 2. And then the sine of 60 would be root 3 over 2. So let's go ahead and multiply those out. We have a negative times a positive, which is a negative. Multiply tops gives you root 2. Multiply bottoms gives you 4. On the second one, when we multiply these two, we will get a negative. So you have a negative negative, so that'll be a plus. Root 2 times root 3 is root 6. And on bottom, you have 4. And I believe that's actually the exact same answer that we got on the last one. That'll be, and you can write it at the negative root 2 first, but again, I like to write my positive first, my negative second, and then that'll be all over 4. Now, I do want to do one thing. I want to just show you that, again, there's multiple ways of solving this, and I want to go to actually the answer key here and show you what they actually did. They used looks like the values of 45 and negative 120. 45 minus 120, and they used a completely different identity. They used the difference identity instead of a sum, and went through the process and got negative root 2 plus root 6 all over 4, which is the exact same answer that we got. So I just want to show you that it doesn't matter as long as they add or subtract to give you the value that you're looking for. It doesn't matter which direction you go with it. Okay, the tangent of pi over 12. Now, one thing I do suggest is I enjoy working with degrees more than radians. So 180 divided by 12. Again, this is 180. This is the tangent of 15 degrees is what we're looking for here. So let's go back to our unit circle, and we're looking to add or subtract. And since we ain't done any subtraction, we'll try to subtract this time. Add or subtract to give me 15 degrees. Now, this one, I feel like this is your best bet. 45 minus 30, you could do 60 minus 45. Would also give you the same. You could do 135 minus 120 if you wanted to. But if you can stay in the first quadrant, since everything is positive in the first quadrant, you don't have to worry about signs, SIGN signs as much. So we're going to take and we're going to rewrite 15 degrees as the tan of 45 degrees minus 30 degrees. And then we're going to scroll back up and look for the identity that matches the tan of 45 minus 30, and that would be this identity right here. Now, it's a little bit uglier identity. The tan of A minus B, we have tan A minus tan B. So let's scroll down and do tan A, which would be 45, minus the tan B, which is 30, all over, and let's scroll back up and look at our identity, 1 plus tan A tan B. So on bottom we have 1 plus tan A times tan B. And again, from there on out, it is simply just evaluating each exact value. We know the tan of 45 is 1, minus the tan of 30 is root 3 over 3. On bottom, we have 1 plus. Again, tan of 45 is 1 times the tan of 30 is, again, root 3 over 3. And we know that 1 times anything is just that value, so we can kind of get rid of that. Now, the cleanup here is a little bit uglier. What we're going to have to do is on top, we've got two values we got to subtract. On bottom, we have two values we have to add. So this will actually help us get a little bit better at our basic math. So before we can add or subtract fractions, we have to have a common denominator. So this 1 over 1, we're going to multiply top and bottom by 3. We're actually going to turn it into 3 over 3. And let's go ahead and save ourselves a step and do the exact same thing on bottom. So now we can actually add and subtract those. So since you have a common denominator on top, that's going to turn into 3 minus root 3 all over 3. And on bottom, you'll have 3 plus root 3 all over 3. Now, again, this is what we call a complex fraction. It's a fraction divided by a fraction. And if you don't remember to divide two fractions, you flip the second one, which that would be the bottom one. You flip it and you multiply. Now, anytime you have things on top of a fraction bar or on bottom of a fraction bar, there are implied parentheses there. So I just want you to remember that this 3 and minus root 3 are grouped together. This 3 and 3 plus root 3, they're grouped together. But these can be canceled. So you have in your next step 3 minus root 3 over 3 plus root 3. And a lot of people will actually leave their answer there. But we actually have a problem with that. We have a radical on the bottom. So let's go one step and just remind you how to rationalize rationalizing fractions. If you have a radical on bottom, we can actually multiply top and bottom. If you don't remember, if it's a binomial, we're going to multiply top and bottom by the conjugate. So we're going to multiply top and bottom by 3 minus root 3. And oddly enough, the top is already 3 minus root 3, but we're going to go ahead and do that. And to do it, we actually have to FOIL. We're going to do 3 times both of these. Then we're going to do root 3 times both of these. So we now have 3 times 3 on top is 9. 3 times negative root 3 is negative 3 root 3. We can't multiply them, but we always put the number in front of the radical. Then we're going to come to here and multiply negative root 3 times both of them. Negative root 3 times 3 is also negative 3 root 3. And then negative root 3 times negative root 3 is a positive. Multiplying a root 3 times itself gives you just plain 3. There's your top. You might be thinking, it looks like this is getting uglier, and it is going to clean up in just a second. On bottom, to multiply conjugates. Now, shortcut for conjugates, we do not have to worry about the insides and outsides. We simply have to multiply first and last. So 3 times 3 gives me 9. Positive root 3 times negative root 3 is a negative 3. So the bottom cleans up to be just 6. So we now have on top a 12. Negative 3 root 3 and negative 3 root 3 is a negative 6 root 3. You can think of that as being like negative 3x and negative 3x. On bottom again, I said we had 6. We can now use the distributive property to divide each by 6, and that gives us a 2 and a negative 1 root 3, which looks much cleaner than our previous answer. So 2 minus root 3 is where we're going to leave it. Next problem. We have the cosine of negative 19 pi over 12. And again, we're going to take and we're going to plug in the 180 for pi. We're going to do 180 divided by 12 times 19. And that gives me the cosine of negative 285. And again, that 285 is not going to be something you find on your unit circle. We're going to have to look for things that add or subtract. And again, I like to always add a rotation. If I'm dealing with an ugly negative number, it just makes it so much easier. So when I add that 365 to 280, I get a value of 80 degrees, which would be much easier to find values that add or subtract. So let's go to our unit circle and let's try to find two values that add or subtract, to give me 80 degrees. And I believe I misadded on that. That should actually be 75 degrees. After I looked at the unit circle for a while and couldn't find anything, that was a red flag that obviously I did something wrong. So 75 degrees. Now it's super obvious that we can use 45 and 30. So let's do the cosine of 45 plus 30. And again, I'm going to use the cosine of a plus b that I used a while ago. Cosine a, cosine b, minus sine a, sine b. Notice the sign change. It's a plus here, but we're going to use a minus here. So let's go ahead and write all of those out. Cosine A, cosine B minus sine A, sine B. And all of those values are super simple values to find because they're all first quadrant. So cosine 45 is root 2 over 2. Cosine of 30 would be root 3 over 2. Minus sine 45, also root 2 over 2. Sine of 30 is a half. Now you're going to start noticing that a lot of these answers look very similar. Multiply tops, multiply bottoms. Same thing here. And you actually get, on the other ones, I think we got root 2 minus root 6. And on this one, we get root 6 minus root 2. All over 4. There's your common denominator. Okay, the next one, number 5. We're doing the sine of 7 pi over 12. So again, let's change this to degrees just so it's a little bit easier. Pi over 12 is 15 degrees, so 715, that'd be the sine of 105. And we'll try to use a subtraction identity this time since we've been using mostly adding. So 105, let's see, we could do 135 minus 30. Those two would work to give us a 105. So the sine, let's try that again, of 135 minus 30. Let's try to find our identity to match it, the sine of the subtraction of two angles. That'd be the difference over here. The sine of A minus B is sine A cosine B minus cosine A sine B. So that's what we're going to use. Let's go ahead and plug in, there we go, all of my values. And there we go. We've got everything plugged in. Again, it was sine A cosine B minus cosine A sine B. 135, let's go ahead and sketch that out. 135 is in the second quadrant. All students take calculus, so sine value will be positive. This reference angle right here will be 45, so we can mark that out. It is positive, and put a 45 in its place. Sine of 45 will be root 2 over 2, times the cosine of 30 would be root 3 over 2, minus the cosine, since we're in the second quadrant, cosine will be negative, so let's go ahead and put our negative there. Again, my reference is 45, so that'd be root 2 over 2 as well. Sine of 30 be a half. Multiply tops and bottoms, that'd be root 6 over 4. Negative times a negative be a positive. Multiply tops and bottoms, and that'd be root 2 over 4. So again, looks very similar to some of our other problems. Root 6 plus root 2 all over 4. And again, just to let you know, it doesn't matter which angles you choose, you're going to come up with the right answer as long as they add or subtract to give you that 105 that we were looking for. Next one, tangent of negative 13 pi over 12. Again, pi over 12 would be 15 degrees, so that'd be the tangent of negative. We got to multiply 13 times 15, and that gives us 195 degrees. And the way they work it in the examples, if you ever look back, they leave the negative, and I just really don't like doing that. I like to add that rotation to it. Makes it so much easier. And if you do that, you're going to get 165 degrees if you add that 360 rotation to a negative 195. And now let's try to find two angles that add up to or subtract to give me 165. And the one that I'm going to use, I believe that would be 120 and 45 if we added them. So that would be my A and my B. So let's find our identity that we're going to use. That'd be the tangent of the sum. So we're going to use this identity here. On top, you have tan A plus tan B. So the top will be tan A is 120 plus tan B is 45. On bottom, scroll back out. On bottom, you have 1 minus tan A tan B. So that'd be 1 minus tan 120 times tan 45. Now notice I'm in a bad habit. A lot of times I won't put my degree symbol, but just keep in mind that these are in degrees. So 120, to do that, we're in the second quadrant somewhere. All students take calculus, so tangent here will be a negative value. We are 60 degrees away from our x-axis, so we're doing the tan of 60, which is root 3, plus the tan of 45 is 1. On bottom, we have 1 minus, again, the tan of 120 was negative root 3. Tan of 45 is 1. You can go ahead and multiply those, and it gives you negative root 3 times 1 is negative root 3. Again, I want to rearrange these and put my 1 first and my negative root 3 second just to make it look a little bit better. And on bottom, we have 1 minus would be 1 plus the square root of 3. And I told you the last time we did a tangent problem, we're not going to leave it like this. Now, this one was a little bit easier. We didn't have to worry about finding common denominators and adding the tops and bottoms together. We had a clean root 3 there. So what we are going to do is, in order to get rid of this radical on bottom, we're going to multiply top and bottom by the conjugate of the bottom. So we're going to multiply top and bottom by 1 minus root 3. And notice the pattern that the tops actually ended up being the same again, and that's going to happen. So we're going to distribute our 1, and that gives us on top 1 minus root 3. We're going to distribute then our negative root 3, and that's going to give us another negative root 3. And then negative root 3 times negative root 3 would be a positive. Root times itself would be 3. On bottom, since they are conjugates, all we have to multiply is first, 1 times 1, and then a positive root 3 times a negative root 3, which is a negative 3. Combining like terms on top, we have a 1 and a 3, which gives us a 4. A negative root 3 and another negative root 3 gives me negative 2 of those root 3s. On bottom, 1 minus 3 gives me a negative 2, and now I can simply distribute a property. And it looks a lot like the last problem. 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is a positive 1. Leave the root 3. And you can write it like that, or if you'd like to put the root 3 first and the minus 2 second, either way would be fine. Okay, on number 7, we have a slightly different set of directions. It says, let me scroll out, find the exact value of each expression by applying the identity. So these a little bit trickier. It says, given that angles A and B are in quadrant 1. This is going to be important information. So we're in quadrant 1, A and B. So since they're both in quadrant 1, everything's positive. So that makes this first problem a little bit easier. And it also tells me the tangent of A is 7 over 24. The tangent of B is 15 over 8. Well, what's the tangent of A plus B? Well, the way that we're going to find the tangent of the sum, and here's what's cool about these problems. Now, one way of working these, we could actually find out what angle A is and what angle B is by using this. We can move tangent over by doing inverse tangent. We could figure out what those angles are. Then we could add the angles and take the tangent of it, and that would give us a decimal answer. But we don't want a decimal answer. We want to actually find this answer without even knowing what angles A and B are. And the way we're going to find that, I know that the tangent of A plus B, let me go ahead and write down the identity for that. There we go. So I know that I can find the tangent of a sum of two angles by using this identity. And once I plug in these tan A's and tan B's, it's going to tell me what the tangent of the sum is without ever knowing what the two angles are. So all I have to do, okay, I've got my identity. This was what I was looking for, tan of A plus B. So I'm going to take the identity and simply plug in what is tangent of A plus the tangent of B is 15 over 8 over 1 minus the tan of A is 7 over 24 times the tangent of B again is 15 over 8. And once I clean that up and evaluate it, I've got my answer. That's all you have to do on these problems. So I do need a common denominator. So what I'm going to do is multiply here, top and bottom by 3. And I'm going to go ahead and just erase that. 15 times 3 is 45, just to save some room. 8 times 3 is 24. So on top, I can add those now. That is 52 out of 24 over. To multiply these two together, I simply multiply tops and bottoms. I can cross cancel. Let me use a different color to do that. 15 and 24 are both divisible by 3, so I can make that a 5 and an 8 just to make it look a little bit better. So I now have on bottom 1 minus 35 over 8 times 8 is 64. On bottom, I do have a subtraction, so I'm going to have to find a common denominator there. 1 over 1, I can change to 64 over 64 so that I can subtract those. On top, I have 52 over 24. On bottom, I have 64 minus 35, which is 29 over 64. I do have a complex fraction now. To divide two fractions, I flip the second one and I multiply. So that's going to be times 64 over 29. 29 is actually a prime number, so it will not cross cancel. However, 24 and 64 will. I believe 8 will divide into both of those. 8 into 24, again, I'm going to use that different color. 8 into 24 goes 3 times. 8 into 64 goes 8 times. So on top, I have 52 times 8, which is 416. On bottom, I have 329s, which is 87. If you'd like to leave it improper, that is the value of the tangent of a plus b. And again, you are able to find the tangent of the sum of those angles without even knowing what those angles were. Now, the next one, let's see, given that angles A and B are again in quadrant 1, so this one's going to be pretty simple as well. Find the sine of A plus B. Now, let me go ahead and write down. I know that the sine of A plus B is equal to sine A cosine B plus cosine A sine B. Now, this one will be a little bit trickier because sine A, I've got that. Cosine B, I've got that. So I've got both these pieces, but I don't have cosine A and sine B. Now, here's what we're going to do. Since I know that the sine of A, I'm going to come over here and I'm going to sketch me out what A looks like. So I know that A is in quadrant 1. Let me erase that. A is in quadrant 1, and I know that the sine is 5 over 13. So I know that sine is opposite over hypotenuse. So I can use Pythagorean theorem or my Pythagorean triples, a squared plus b squared equals c squared, to find out that this value is 12. So I know that the sine of A is 5/13, and I now know the cosine of A is adjacent over hypotenuse, which would be 12 over 13. So I now have this piece. And I know the cosine of B is 4/5, but I don't know the sine of B. So we do the exact same thing. Since we're in the first quadrant, I'm going to draw me an angle B here. Here's angle B. I know that cosine is adjacent over hypotenuse. And I also know by Pythagorean theorem, this is a triple. This is a 3, 4, 5. So I know that the sine of B is equal to opposite over hypotenuse, which is 3/5. So now I've got everything for my formula. So the sine of A was 5/13 times the cosine of B was 4/5 plus the cosine of A was 12/13 times the sine of B was 3/5. Now let me show you a trick. Just to think ahead, we're going to be very tempted to cross cancel these fives. However, if you'll look at both bottoms, you're about to have to add these two fractions together. Right now, both bottoms are the same. So I wouldn't even cross cancel. I would do 20 over 13 times 5 is 65, plus 12 times 3 is 36 over 65. And notice, whoops, said one thing, did another. The bottoms are the same. So you don't have to worry about finding common denominators if you don't cross cancel. That'd be a 56 out of 65, and that does not reduce. That is the value of sine of A plus B. Again, we do not know what A is. We don't know what B is. We didn't have to find them. We were able to find the sine of the sum without finding each individual angle. Okay, number 9. Given angle A is in quadrant 1 and angle B is actually in quadrant 2. So this will be a little bit different. Find the cosine of A minus B. So let's go ahead and write down the formula for the cosine of A minus B. So in order to find the cosine of A minus B, there's the 4 things we're going to need. We're going to need the cosine of A and B. We're going to need the sine of A and B. We have the sine of A, we have the sine of B, but we don't have the cosine of either one. So we're going to go through the exact same method we did on the last one. And luckily, they gave us triples again. So we have sine of A So I'm going to draw A, and it does say that A is in quadrant 1. So I'm going to draw it over here in quadrant 1. So here's angle A. I know that the sine of A is 12 over 13, so that'd be opposite over hypotenuse, and that is a triple. That is a 5, 12, 13. So I know that the cosine of A would be adjacent over hypotenuse, would be 5 thirteenths. Now let's do the second one. They tell me that angle B is in quadrant 2. So I'm going to draw it over here in quadrant 2. I know that the sine of B is 4/5. That would be, and notice that all students take calculus. That's very important. Sine is opposite over hypotenuse. So I know that this is a 3, 4, 5 right triangle, but you've got to be careful now because cosine of B will actually be a negative value because all students take calculus. Since we're in that second quadrant, make sure that you put that cosine will be negative. And cosine is adjacent over hypotenuse, so it'll be negative 3/5. So now we've got all the pieces we need. The cosine of A is 5 over 13. The cosine of B was negative 3/5, plus the sine of A was given to us in the directions, that was 12 thirteenths, times the sine of B was also given to us, that was 4/5. And notice again, you do have the common denominator in bottom, so I would not mess with it. So you got with cross canceling. So you got negative 15 over 65 plus 48 over 65. You can now add them together. Negative 15 and 48 gives me 33 over 65, which will be the value of the cosine of A minus B. Okay, for problems that we have on this, we're going to use sum and differences to do proofs. And we've done proofs previous lesson, so we're just going to do proofs again. And we want to somehow prove that the sine of some angle minus pi is just the negative sine of that angle. So the way we're going to do that, what I notice is the left side here looks a lot like what we've been doing. It's a difference. So let's go over here to the side and write down our difference identity. And there it is. And I just want to point out that on the left side, and what we're trying to do, we're trying to make the left side look like the right side. That's simple as that. So I'm going to work on this left side, and now the left side looks a lot like this identity to where A is my theta, B is my pi. So I'm going to take out, let's work on that. I'm going to take out all my A's and plug in thetas, take out all my B's, plug in pi's. So I now have the sine of theta, cosine of pi, minus cosine theta sine pi. Now, just a quick reminder that pi is 180. So I know that the cosine of 180 degrees is negative 1. So I now have the sine of theta times negative 1 minus the cosine of theta, and the sine of pi is actually 0. So this goes away, minus 0. So it gives me sine of theta times negative 1, which is the negative sine of theta, which now matches the right side. Next problem. Number 11 has the cosine of a sum. Now remember that the cosine of a sum fits this. The cosine of A plus B is the cosine of A times the cosine of B minus the sine of A, that'd be 2, times the sine of B. And that, again, we're working on the left side here, trying to make it match the right side. So is the cosine of 90 plus an angle. So can you take an angle, add 90 to it, and that's going to be the same thing by taking the cosine as finding the negative sine of that angle. Let's see. So the cosine of 90. Again, the cosine of 90 is 0. So 0 times anything is 0. The sine of 90 is 1. So this is going to be negative 1 times the sine of theta, which is the negative sine of theta. So that matches up once again. There's your proof. Number 12. These last two will be done very similar to those first two. So this one says, I can take the tangent of some angle and add 180 to it, and it's going to be the same thing as the tangent of that angle. And we already know that this is true because think about tangent. The period for tangent is 180. So if I have like the tangent of 30 and I add 180 to it, and that's 210, is the tangent of 30 and 210 the same thing? Yes, because it repeats every 180 degrees. So let's go ahead and see if this is true. So the tangent of pi plus theta, and let's go ahead and plug that into the sum tangent identity. That says the tangent of a plus b is equal to the tangent of a plus the tangent of b over 1 minus tan A times tan B. Now this one looks like it might be a little bit trickier. Okay, so the tangent of pi, again, pi is 180 degrees. The tangent of 180 is 0. So you have 0 plus tan of theta on top, which is the tan of theta. On bottom, you have 1 minus. Again, the tangent of pi is 0. 0 times anything is 0. So maybe it was a little bit trickier. So you have tangent of theta over 1, which is simply the tangent of theta. So it does match up. And the last one, the cosine of a minus b, we're going to apply that to the left side. That's going to be the cosine of a times the cosine of b plus the sine of a times the sine of b. And we're going to try to make that match the negative sine of theta. Now, 3 pi over 2, that's 270 degrees. That is a quadrantal angle. That's right here. The cosine of that 270 is 0. 0 times anything is 0. The sine of that angle is -1. So you have -1 times the sine of theta, which does equal the negative sine of theta. So they do match up.